So I want to show you about how we use spreadsheets for your lab tomorrow. So here's the pre-lab. Nothing too particularly devastating about it, although you look at this and you say, oh my gosh, what did I just say yes to? So what I'm going to do is I'm just going to copy and paste this. So copy. And I just happen to have a spreadsheet open, paste, hooray. Let's get rid of this row. I don't like necessarily all the borders, so I'm going to remove all the borders. These values here that say -1, 2, 3, that's just because of the fact that we had formulas there. So what I'm going to do is I'm just going to start copying and pasting because that's easy enough. So into spot 1, I have that, which will immediately give you this, uh-oh, that's okay. Spot 2, that will go, and we'll just keep this train rolling. You're noticing that it's saying, uh-oh, we have errors, and you'll see why, because I'm missing parts of this. Once we add one part, it will all get solved. So here it says value, so let's add in a value, 0.5. Here it. Well, had to do with the fact that I copied and pasted them. Go figure. So it's all working just fine. You might have to retype them, which is kind of annoying. So if F2 equals AA, oh, guys, you can make me. Oh, I see what it is. It's the quotes. It doesn't understand smart quotes. There we go. So, problem solved. You got to watch me problem solve. So, what I have here is I created a probability function, which is here. So it's randomly picking some number somewhere between 0 and 1. And if the number turns out to be less than or equal to 0.5, it's saying it's an A. If not, it's saying it's a B. And then here, the concatenate is just combining the A and the B, which gives you this. Here, what we're doing is we're saying, hey, if this spot here is AA, give it a 1. If not, give it a 0. So if this is true, do this. If not, do this. Here we're saying, hey, if this one AB, then let's call it a 1. If not, let's double check. Are you a BA? If you are, it's a 1. If not, it's a 0. And here, if you're a BB, hooray. So if I were to highlight these and click and drag, I can get some patterns set up. Although, hold on. I need to fix one part. That is, I need to add those dollar signs. What those dollar signs do is lock it in place. There we go. So what I got was a whole bunch of data. So I could sit there and say like this is 0.9 or whatever. If I have that, what I can then do, if I so felt like it, is I can add these up. Of H2 to H17. I can multiply, have that value, copy, copy. What you notice is every time it keeps messing with stuff, and that's because every time you mess with one of these, it's going to reshuffle the randomness. The point of all this is I can now figure out my p-value, and I can figure out a q-value. How could I do that? My p-value is going to be this times 2 plus this divided by the total of H18 to J18. Oh, times 2. Just kidding. And then I could do here plus, oh, there times 2 plus here divided by the sum, or 2 times the sum of H18 to J18. And hey, look, those turn out to match. Well, what could I do with this? Well, if I'm eliminating a certain allele, I can use this to say, hey, look, well, maybe just by random chance, I can eliminate the P's or the Q's, so maybe I can eliminate those 5s, and if I eliminate those 5s, what does that do? And we could then calculate out the P values and the Q values, and then we could use those values for the next generation. Or what's going on here is if I were to just take the straight P and Q value, I'm not selecting anything. This just turns out to be randomness. So what I can do is I can keep inserting cells. And the more of this I do, the more my numbers start to shift. And if you notice here, it actually automatically adjusted where all these numbers are. What I would probably do is actually probably move this up to the top if I had to do this again. And if I felt like it, I could say, okay, so 0.48, okay, 0.48 or 0.47, what was it, 477? Yeah, 477. Well, what'd that do here? Now it changes to 0.45, 0.45. Hey, look, now I'm at 0.43, 0.43. Hey, look, I'm now back at 0.477. Now I got a 0.432, 0.432. Hey, look, we kind of like stabilized ourselves, and we can keep doing this. We felt like it. I can manipulate what's going on down here. I can manipulate that to go up here. There's all sorts of things I can do. If I were to eliminate something, like if I were to say, oh, the heterozygotes are bad, what I would probably want to do is if I were to type A0 here, oh, look, we went back to our p-values of 0.5 and 0.5, which I could then go back and plug into here, see what happens, and oh, look, I now have a 0.64. Then as a 0.64, now it goes to a 0.72, 0.72, which now goes to a 0.92. Now that goes to practically a 1. We've locked it out. So we could do things where we can eliminate individuals and see what that does to how things shift. This obviously here is not necessarily a huge population. I'm going from 2 to 23, so that's a population size of 21. I could do this so I have a couple hundred. How do I do that? I just keep clicking and dragging all the way down. So I can manipulate population size. I can introduce organisms if I so felt like it. If I could insert a line here and I could sit there and say, you know what, we're going to throw in 10 more, or we're going to throw in 10 of these individuals. How is that going to warp things? Oh, look, it warped. So now I could take these numbers and put them back in here and see what that does. And oh, okay, those guys went away, but we added 10 who are this way. Oh, look, we shifted the numbers. So I can actually do a lot of manipulation here. It's just a matter of thinking through what am I doing. And have fun. But keep track of what you're doing. It would help if I were to make successive spreadsheets on this. So I could go spreadsheet 1, spreadsheet 2, blah, blah, blah.